So on Earth, we are living on quite a few different systems of the timing. Say local time, okay, and the central time, certain standard time. But also in terms of the, I would say in terms of viewpoint of aliens, they actually, our Earth time is not so true compared to the supposed to be measured in the universe. And again, here we have been seeing this before, but let me draw this one quickly. So say here is right now we are, and so for example, at certain regions on Earth at this moment, and the sun is right on top of their head, okay? And this is the Earth. And so, for example, here this one is the orbit of the Earth in space around the sun. So here is our definition of our Earth day. So to the next day, the same person at the same locations, if he sees the sun right on the top of his head, so from here to here, we define is, we call it one Earth day. Okay, and that is what we've been familiar with as the 24 hours. Okay, but in reality, supposed to be is this. Say if the certain observer outside the Earth looking at the movement of the Earth, and they place a vector like this. So basically from here, this vector has been moving to here more than 300 degrees to these positions. So in a one Earth state, Earth has been rotating for more than one rotation. So here suppose, on the total one rotation of the Earth, they must be in this rotation. So that means always it's a vector pointing to the direction of the sun. So this is called the sidereal day. So from here to here. Okay, and this is the date we're supposed to be using to use for measurement of the angles for everything once you travel in, say, for example, in space. And that is the time we must pick it up. So here, keep this in mind. We have the Earth date, we have the sidereal date, and all the calculations in terms of the angle of the time we should base on this one. So last time we have been talking is here we have one Earth, or sometimes people simply so that's a solar day. And that is a little bit more than one sidereal day. How much more? 1.00273 790 and 93 sidereal day. Okay. So keep those things in mind, and then we can talk about how to measure the angles. We have two terminology, GST, and that's called the Greenwich. Sidereal time. And we have LST. So right now I highlight this term. Basically here this time is not measured in terms of our Earth time. Okay, and that really is measured in terms of the true rotations of the Earth. And has been observed by aliens outside the Earth. Okay, so for anything we're going to measure is this. So for example, this is our y-axis, and right now this is the geocentric coordinate systems, and this is J and this is K. Okay, and this is part of the Earth. So here, for example, this is the equatorial plane. And what is the Greenwich sidereal time? So, for example, on the surface of the Earth, say the Greenwich, say at a certain moment is here. So we draw a longitude, okay, and that is the intersection of the longitude. So basically, this one is the theta GST. Okay, so theta GST, basically here is measured in terms of the angle, okay? And measured in terms of the angle, actually in terms of the rotation 360 degrees, we can always convert the angle into hours, minutes, seconds, etc. So really we tell the time really is in space, is tell the angle that being passed, how many angles we pass through a reference. For example, here is y-axis. Okay, so so that's kind of notation, and then the local sidereal time. So for example, here because people pick up the Greenwich as the common reference, and also the latitude, the longitude, we call sometimes for the I forgot the term. And we also pick up the longitude where the passing the Greenwich as the reference to define the longitude of any space, any location on space. So, for example, here, say, so say here Fairbanks is here. Okay, I just actually make it up. So here we draw the longitude of the Fairbanks, and then we link into here. So from this case, this angle, we measure from I to here, and this is defined as the theta LST. Basically, local sidereal time, that is the how much the angles or the how much time we pass through a reference which we pick up as the I-axis. Okay, and actually by looking at here, the difference between the Greenwich and any site on the space, basically that is defined as our longitude, our conventional term of longitude. So for example, for this is longitude, okay. So basically here the formula is local LST equal to the GST plus whatever the longitude is. Sorry, here I use lambda. Okay, lambda is the longitude. So for example, the Fairbanks have the lambda equal to, I think, minus 147 something. Okay, so later I have a number that I will fill in, but that is 100 minus. And the minus, that means it's west. We always measure the east, defined as the positive, and west is negative. So that is the first thing we define. And so for here, we can exercise a few examples here. So say, in the year of the January 1st of the 1968, the theta GST on the beginning, I would say the 0 on the 0 hours, 0 minute, and 0 seconds on this date. So just at the beginning of that new year, on that time, the theta st, so that means in space, alien look at the Greenwich, the angle theta GST equal to 99 degrees point 721208. Okay. And another example is, say, for example, the next year, 1 year later, 1969, and 0 and just in the midnight, past the midnight. So the theta GST will be equal to 100 degrees point 468137, and etc. We have, you can look at the almanac and look at the whole thing. Here I give you the handouts for this year. 1, 2, 3. Can you pass down over there? 1, 2. 1, 2, 3. 1, 2, 3. So I give you the handout for it's a little bit hard to find this one. So that is for this year, for this month of this year. And from there, GMST basically is the GST, okay, the Greenwich, and what is M? The mean sidereal time. Okay, so from there, you can convert. So for example, for this example, on the October 1st of this month, 2017, and from here we are given is hours, so that means the theta GST equal to 0h and 39 minutes and 40.7 seconds. How to convert it into degrees? Very easy, because for here we 1 hour basically equal to 360 degrees divided by 24, and that is 115 degrees. Okay, etc. So basically 1 minute will be equal to 15 degrees divided by 60, that is 1/4.25 degrees. So with that kind of the conversions, we can always convert it. So basically, if you want to convert it, basically here is, say, for example, 39 minutes times the 0.45 degrees. So that's the degrees, and plus 40.7 and divided by seconds, that is starting from minutes and one more division by 60, and that is in the unit of degrees. Are we okay? Okay, so that is the way we're doing this one. So from here, vice versa, if we have given in terms of the format of the time, the minutes, hours, we can convert it into degrees. So here I just want to show you due to the rotation, the movement of the Earth with respect to space, and also due to, if you look at it in detail, actually the Earth, the past trajectory about the Sun is not so perfectly circular. Basically, they have a little disturbance. Okay, so due to many reasons, and the beginning of every year of the Greenwich that respect to this reference basically is changing. Okay, so here we always need to look up the tables for the reference. As long as we know the reference starting, then we can always calculate with the map, then we can determine this one. So basically this one can be determined as long as we know this one. Okay, so that's the key. And this calculation can be a little bit tricky. And actually, in the second part of the homework, I designed a few, and for everyone to exercise these. And we can look at one example here. And let me take one example. So that probably we can start with it.